All right, what if I told you that you could get top-tier AI results without any of the usual training? It sounds kind of wild, right? Well, today we're diving into something called TabPFN. It's a model that's basically flipping a core idea of machine learning completely on its head. So forget the grind, because this is something else. Let's get into it. Okay, first, let me ask a question, especially for anyone who's ever worked with data. How much of your life have you spent just tuning models? You know what I'm talking about, all those hours, maybe even days or weeks, just tweaking and tuning hyperparameters, getting those settings just right. Man, it's such a massive part of the job. And let's be real, that whole process gets especially painful when you're dealing with tabular data. You know, the spreadsheets, the databases, pretty much the stuff that makes the world go round. That endless cycle of train, tune, predict, repeat, it can feel like you're just stuck on a hamster wheel. But what if you could just skip that whole part? And that, my friends, is exactly where TabPFN comes into the picture. So what is it? Well, it's a pre-trained transformer built specifically for tabular data. And its whole promise is incredibly simple: a zero-tuning solution that just works right out of the box. So the magic here is that TabPFN makes its predictions in what's called a single forward pass. Now, what that really means is no more endless optimization loops, no more tweaking all those little knobs. You literally just feed your data through the pre-trained model one time, and bam, it gives you a super high-quality prediction. It's a total fundamental shift in how we approach this stuff. And the benefits? Oh, they're pretty staggering. I mean, zero tuning, that's huge, obviously. But get this, it often outperforms finely tuned industry standards models like XGBoost. It just natively handles messy, real-world data. It's super strong on small or noisy datasets. And the real kicker? It does all of this in seconds. Not minutes, not hours. Seconds. Okay, so at this point, you're probably asking the same thing I was. How is this even possible, right? How can a model just make a prediction without being trained on your specific data? Well, the answer lies in this really powerful concept called in-context learning. And the process is actually, deceptively simple. So step one, there's this massive one-time pre-training phase where TabPFN learns from millions of synthetic or artificial data sets. The best way to think about it is like a student who doesn't just study one textbook for a test. They study the entire library. It learns all these universal patterns of how data works. So then when you show it your specific problem, it's like, oh yeah, I've seen something like this before, and it instantly recognizes the patterns and spits out a prediction. I mean, this just completely changes the game for the machine learning workflow. The old way, it's that long, complicated cycle. Train, tune, predict, then do it all over again. The TabPFN way, it's so simple it's almost funny. Provide data, get a prediction. That's it. The efficiency gain here is just massive. Okay, but look, theory is one thing. Cool ideas are great, but performance is what really matters, right? So let's see how TabPFN actually holds up when we throw some real-world data sets at it. Time to put it to the test. So first up, we've got a classic binary classification task. We're going to try to predict whether a tumor is malignant or benign using the breast cancer Wisconsin dataset. And yeah, this is a serious one. We're talking about a prediction that could have life or death implications, so accuracy here is absolutely critical. And the result? A staggering 97.34% accuracy. Now, let me be super clear about this. That's straight out of the box. No prep, absolutely zero tuning. That's an incredible performance for any model, let alone one that didn't even need to be trained on this specific data. But, high accuracy is only one piece of the puzzle. The model also hit a 0.95 ROC-AUC score, and what that really measures is how confident the model is in telling the two classes apart. So a perfect score is 1.0, and a square of 0.5 is basically just a coin flip, pure random guessing. Hitting 0.95 means TabPFN isn't just getting the answer right, it's doing it with near perfect confidence. Okay, so it absolutely nails classification. That's clear. But what about regression, where you have to predict an actual number, a continuous value? For that, we're going to look at the California housing dataset and try to predict median house prices. And guess what? The results are just as strong here. It got a really low mean squared error, which is great, but check out that R-squared score, 87%. To put that in plain English, it means the model was able to explain 87% of why the house prices were what they were. For a messy, complex, real-world dataset like this, that is an excellent result. You know, this quote from Merlin AI really just hits the nail on the head. Within seconds, without any tuning training, the performance is excellent. It's that combination, right? The incredible speed, getting these amazing results in seconds, and the top-tier performance without any of the usual work. That's what makes this whole thing so revolutionary. All right, so let's bring this all home. What does a tool like TabPFN actually mean for you, for your projects, for your day-to-day work? Because this is about way more than just a cool new piece of technology. It's really about a whole new way of working. So where does this thing shine? Where should you pull it out of your toolbox? Well, definitely for rapid prototyping. You can get a crazy powerful baseline model up and running in minutes. It's amazing in low data scenarios. Think about fields like biomedicine or drug discovery, where every single data point is gold. You can also use it to quickly benchmark your own custom-built models and see how they stack up. Basically, anywhere that speed, simplicity, and accuracy are all critical, TabPFN is going to be a game changer. So the big takeaway here is this. TabPFN isn't meant to come in and replace every single tool you already use. That's not the point. Instead, you should think of it as this incredibly powerful new tool in your arsenal. It's a drop-in solution that can just dramatically speed up your workflow and, a lot of the time, give you state-of-the-art results with practically zero effort. And that really leaves us with a fascinating, kind of mind-bending final thought. For so long, we've thought of machine learning as this process of painstakingly, carefully training a model on one specific dataset. But what if an AI can learn the general rules of the game so well that it just doesn't need that step anymore? What does that mean for the entire future of machine learning? Definitely something to chew on.